Hello and welcome to another engineering video with Joseph. Today we'll be discussing steel. First, I'd like to make an announcement. I have retired from NASA. I had a great time there, but I'm on to bigger and better things in the steel industry. Now, let's talk steel. To make steel, you need iron and carbon. Carbon's just about everywhere, that's no big deal, but iron is a little harder to get. Iron occurs nowhere on Earth naturally on its own. It always is an iron oxide or iron mixed with another thing. So to get iron, you first have to get the iron ore, iron mixed with other impurities. You start digging in a quarry until you get these large rocks. Now these large rocks filled with ore are too heavy and expensive to transport on their own across land. So one solution is to float them down a river to an iron processing place, like a furnace. Now they're still too big and there's still too much things that aren't iron in them. So to get them ready for a furnace, on site in the quarry, they'll crush them up and then take the crushed up bits of iron ore and put them in a tank where they'll use froth flotation, where compressed air is pushed into the tank, and this separates the iron ore from other rocks. They then take that iron ore, float it down a river towards the furnace, where it's mixed in with coke and flux and methane gas in some cases to introduce carbon to the iron as it's being refined. Now, once you have refined iron with a proper percentage of carbon in it, you get a finished product that looks sort of like this. This has been drawn as though it were a cross section or an etched piece of iron so that you could see the scales inside of it. Each of these scales roughly a similar size. Once the iron's been worked down on rollers to take a new shape, those scales will get pulled apart, and that's called recrystallization, where they get deformed and elongated. This affects their mechanical properties. The structure inside the steel has changed, and to return it to a more ductile, less brittle position, you need to heat it up again and retemper it. Once all of this has been done and a steel plate is how a manufacturer has specified it to be, it can be turned into a plethora of our day-to-day items and used as a real engineering material. For example, here you have a steel plate that a large hydraulic press will come down on and stamp out the rear sprocket for my motorcycle, which is really important to me because without that I couldn't ride my motorcycle. Or in another example, you could have a die with a shape drawn in it, and then the steel could be pulled through, and it would come out in the shape that the die has made, where that can then be chopped and cut up and welded to make a crash bar cage for my motorcycle. Or in another case, it could be cast, poured while still hot into a mold, where it can make the frame to my motorcycle. Or it could be machined to make the crankshaft and camshaft for my motorcycle. At any rate, steel has a lot of applications in our day-to-day life as an engineering material and is very important. The deciding factor in how a steel will behave as a material is its carbon content. The lower the carbon content in a steel, the more ductile it'll be, the more apt it is to being moved and being malleable. And the higher the carbon content, the more brittle or hard it will be. So a pocket knife, you want a relatively high carbon content so that the blade will retain an edge and stay nice and strong. The problem being you can't use these as prying utensils because they'll break. They're too brittle. And that's my video. Thank you very much for watching.